In lesson 10.4, we're going to discuss using mathematical models to make predictions in sports. And more specifically, in this section, we're going to be talking about baseball. You may be familiar with the term sabermetrics. Sabermetrics is kind of a special branch of statistics that we apply specifically to baseball. This was sort of developed in the early 80s by a mathematician named Bill James. And he came up with lots of formulas using many of the statistics that we keep in baseball to make predictions and also to place value on different baseball players. One of the formulas that we're going to look at today is a formula proposed by Bill James called the Pythagorean expectation of winning percentage. And the formula is given in your notes. Here, RS is the number of runs scored by a team, and RA is the runs allowed. And using those two statistics, we can make a prediction about the team's winning percentage. So in example number 1, we're going to look at the Philadelphia Phillies during the 2008 regular season. And during that season, they scored 799 runs. That would be RS in the formula. And they allowed 680 runs. That would be RA in the formula. So with these numbers, we're going to predict their winning percentage for that season. So here's the formula with the numbers substituted in. And when we calculate that rounded to 3 places, we get a winning percentage of 0.580 or 58% of their games. Now, if the season has 162 games, 58% of 162 means that they should win 93.96 games during that season. Now, if our model is good, then our prediction should be fairly close to the actual value, but rarely the predicted value and the actual value will be the same. So the difference between the actual value and the predicted value is what we call the residual of the data. So we're going to write down kind of like an informal formula there where the residual is the actual or the observed data value minus the predicted value that we get from using our mathematical model. Now, if our residual is positive, that means that the predicted value was lower than the actual value. So our prediction was too low. If the residual is negative, that means the predicted value was higher than the actual. So our prediction was too high. So residuals can be either positive or negative, and the direction of the error is given by the sign of our residual. So in 2008, we know that the Phillies actually won 92 games. That's the actual or the observed value. So we're going to then calculate the residual using the predicted value that we got from example number 1. So our actual value was 92. The predicted value from example number 1 was 93.96 games. So the residual then would be the difference of those, 92 minus 93.96, which gives us a residual of negative 1.96 wins. And that means that the Phillies won 1.96 fewer games than expected in that season. However, 1.96 is pretty close, especially in a season of 162 games. So this model actually did a pretty good job of predicting the Phillies' wins. In 2008, the Kansas City Royals scored 691 runs and allowed 781 runs. Calculate their predicted number of wins and the residual if they had 75 actual wins. Okay, so there's a couple of steps to this problem. First, we're going to plug those numbers into the formula to figure out their expected winning percentage. So we do runs scored squared on the top, and then the denominator, we have runs scored squared plus runs allowed squared. That gives us a predicted winning percentage of 0.439. Now we need to calculate their expected number of wins. So 0.439 times 162 games in the season means that we're predicting they should win 71.12 games. Now they actually won 75. So to calculate the residual, we take the actual value minus the predicted value, and that gives us a positive residual of 3.88. And by the way, it's not possible for the Royals to win 71.12 games. But in statistics, we like to keep those decimal places just for the sake of accuracy, and we're going to see where that comes in later on in some calculations. Now, one thing we might be wondering is how do we know if this model that Bill James predicted for the winning percentage is the best model? So let's say that we change that formula a bit, and instead of using powers of 2, we just do powers of 1. So we wrote the formula the same way otherwise, except instead of squaring the runs squared and runs allowed, we'll just do first power. So using this new model then, we'll calculate the predicted number of wins and the residual for each team. So first, let's do the predicted number of wins. Again, for the Phillies, we had 799 runs scored, 680 runs allowed. So if I take those numbers and I plug them into that new formula with runs 799 in the numerator, and then the denominator would be 799 plus 680, that would give me the winning percentage. And then when I multiply that by 162 games, I get a predicted number of wins of 87.48. Now they actually had 92 wins. So if I do 92 minus that 87.48, that gives me a residual of 4.52. I'd recommend that you pause the video at this time and try part B and see if you can get the correct predicted number of wins and the correct residual. All right, for the Royals, the predicted number of wins is 75.98. The residual would be negative 0.98. So notice one of our predictions was too high and the other was too low. Now, to assess which model is better, we want to look at which one gives us the smallest residuals. And as we've seen in the past, when we've looked at deviations, we know that positives and negatives will cancel each other out. And so to avoid that problem, like we did when we calculated standard deviation, we're going to use the square of the residuals. Now, using just the Phillies and the Royals, we're going to determine which model gives us the smallest sum of the squared residuals. So with our original model, which had an exponent of 2, one of our residuals was negative 1.96, so we'll square that, and our other residual was 3.88, so we'll square that. That gives us a sum of the squared residuals at 18.896. With the new model that we just looked at in example number 4, one of our residuals was a positive 4.52 and the other was a negative 0.98. So the sum of the squared residuals there was 21.39. And the original model was slightly better. It had a smaller sum of the squared residuals. So therefore, we know that just using those two teams alone, we would get better results using the original model. Now, ideally, we should find the square of the residuals for every value in the data set, which would mean we would have to check this formula with every MLB team from 2008 and determine which model makes the sum the smallest. This would be called the sum of the squared residuals. So we'll abbreviate that as SSR. And the formula there would be to add up all of the residuals and squared. So actual minus predicted, that would be our residual, and we would square that, and then we would add that together for all the teams in the MLB. Please do homework 10.4 in your assignment packet.